Great. So welcome to grade 8 math again. We are now in chapter 5.5. We are now looking at the area of a circle. So let's just review a little bit of the two formulas that we've already learned, or the two relationships between radius and diameter and between diameter and circumference. Between radius and diameter, we remember that radius is equal to diameter divided by 2, or that the diameter is equal to radius times 2. So half the diameter is the radius. So they're interchangeable. I can go back and forth as long as I remember the diameter is longer than the radius, so that my answer should be a higher number value than the radius. Diameter to circumference, if I look at diameter, or if we look at circumference first, if to get the circumference, I take the diameter and I multiply it by its ratio pi, which means that approximately three times the diameter gives me the distance around, and the other way around, the diameter is equal to circumference divided by pi. So if I took the whole distance around and chopped it into three pieces, or to approximately three pieces, I'll get around the diameter. So this magic ratio is pi, where pi for our cases in our class will just be using 3.14. There are no units because it's just a ratio. It's telling you how many times longer is the distance around compared to the distance across a circle. So again, circumference is always going to be longer than the diameter. What we could do then is we could take this circle and then chop it up into pieces, and the more pieces you chop it up, the better. And so this distance here is the radius. So that's the height of one of these kind of pieces. We'll approximate here. And then what we're going to do is we're going to take half of this circle and take these four triangles and lay them out like so. So that these are these four red triangles. Opening up, just like an orange, I'm opening up the orange and getting the four triangles, kind of triangles with the round bottoms, on one side. The four white triangles on the other side, I'm going to put in between to kind of make this parallelogram. I'm going to chop one of the triangles to bring it to the other side to make it into a full kind of rectangle now. And let's look at the dimensions of it. Well, the height of this is the radius, approximately. The radius is the height of this almost rectangle. Well, the length of this almost rectangle is half the distance around, right? Because it's this white plus white plus white plus white, or red plus red plus red plus red, the bottom parts of it. And if we remember, the entire distance around is 2 pi r, so half of the distance around would just be pi r, is the distance across, or the length of it. So therefore, the approximate area would be length times width, or so the area of this circle is length, which is pi times r, pi r, and then times the height, or the width, which is r in this case. So pi r times r. Well, r times r, we remember in chapter 1, something times itself is itself squared. So this is pi times radius squared. Notice that the diameter is not in this formula, so we would have to find the radius from the diameter in order to actually continue on with this problem. So, and notice the orders of operation. R squared comes first before pi times r. So let's take a look at some examples. Calculate the area of a CD if its radius is 6 centimeters. So the two things that we only need to know in this formula is the area and the radius. The pi will always be 3.14. Area we don't know. Radius is 6 centimeters. So we use the formula area of a circle equals pi times radius squared. I'll fill in my numbers. Area equals 3.14 times, and I'm going to do this just in brackets because I'm replacing it, 6 centimeters squared. The 3.14 stays there, the pi stays there. I could leave it as the letter pi if I wanted to, or I could change it to 3.14. It's up to you, whichever you're more comfortable leaving there. Now 6 centimeters squared, or all squared, I put brackets in there because the squared works on the 6 and it works in the centimeters. So 6 squared, if you remember exponents, 6 squared means times itself. So 6 squared is 6 times 6, or 36. And centimeters times centimeters is centimeters squared. I could now drop the brackets because there's nothing left in the brackets to do. So I do area of a circle is equal to 3.14 times 36 centimeters squared, and the area of the circle is 113.4 centimeters squared. Ideally, I'd like to round to 2 decimal places. If I have a lot more than 2 decimal places, it just ends up with a really long answer, long drawn out. So I'm not going to put all of the decimal places. If I had more of it, I'll just round to 2 decimal places in total. What I'm going to do is I'll solve the following 3 more examples. So example 2, 3, and 4. If you wanted to pause the video, try out these examples on your own, and then I'll work through all the examples so that you don't have to watch through the entire video, and then just see if your answers are right for examples 2, 3, and 4. So let's continue now with example 2. Calculate the area of a wall clock if its diameter is 24 centimeters. Notice it says the word diameter, and because if we remember, the formula of an area of a circle is radius squared times pi. So we need to first find the radius from the diameter. So I can write that over here. Radius is equal to diameter divided by 2. That's an R. Radius is equal to 24 centimeters divided by 2. My radius is 12 centimeters. So ideally, always find the radius first, because from there, I can then find the area. So now I start to put in my numbers, area of a circle. This time I won't change my pi right away. I'll leave it as pi just to practice leaving it as there using less pencil lead. So pi times radius squared. My radius was 12 centimeters squared. Leave my pi there. 12 centimeters squared is 144 centimeters squared. I multiply. Now I can convert this to 3.14 times 144 centimeters squared, and my final answer is 452.16 centimeters squared. Great. Example 3. So I have a shape that kind of looks like a circle, but it's not finished. We can assume that this is half of a circle. So this is what we call a semicircle. And a semicircle is essentially half of a circle. So semicircle is the same thing as a full circle divided by 2. So we'll use this formula a little bit later on. So first we're given this 4.8 meters, and when we look at it, we realize this is the diameter. And again, we don't look like the diameter with area calculations, so we will change this to radius. Radius equals to diameter divided by 2. Radius is equal to 4.8 meters divided by 2. Radius is equal to 2.4 meters. Then I calculate the area of a circle using the formula pi times radius squared. I'll leave my pi in there again. Radius is 2.4 meters, all squared. I square both the 2.4 and the meters, so pi times 5.76 meters squared. And then, so this is 3.14 times 5.76 meters squared, and I end up getting 18.0864 meters squared. Now that's the area of the full circle, and if we remembered what I drew at the very beginning, the area of a semicircle is calculated from the area of the circle cut in half. So I'm dividing it by 2. So the area of the semicircle is 18.0864 meters squared divided by 2, and I get the answer 9.0432 meters squared, which is approximately 9.04 meters squared. Great, so let's do this last example now, example 4. So example 4 says the city wants to add lawn around the city fountain. So I have a fountain here, and it looks like it's a circular shape. If the lawn itself costs 25 cents per square foot, what is the total cost of this lawn, which is the kind of grayed area around this circle? So, well, I have 2 shapes here. I have this circle, which is the fountain, and then the space around makes what it looks like a square. So let's find the area of the circular fountain, and then we'll find the area of the square lawn. And then what we can do is we'll find the relationship between the two and see what we need to do with that one. Well, if we look at the larger area of the square and we cut out the area of the circle, then we'll be left with this other part. So in my head, I'm going to try to get the area of the kind of shaded part is, the way we find that, the area of the square minus the area of the circle. So let's separate them. Let's start with the area of the square. Area of the square is equal to length times width, or length squared, whichever one you want to use. I know the full length is told to be 12 feet by 12 feet. I multiply my numbers together, so 12 times 12 is 144, and feet times feet is feet squared. So now I have the area of the large square, which, if it was all lawn, it would be 144 feet squared. Now I need to find the area of the circular fountain. Now I'm told again that this is 12 feet. Well, this is the diameter, and with the diameter I can't do much, so I need to find the radius. Radius is equal to diameter divided by 2. Radius is equal to 12 feet divided by 2. My radius is 6 feet long. With that information, I can plug that into the formula. Area of a circle is equal to pi times radius squared. So pi times 6 feet all squared. So that's pi times 6 times 6 is 36, and feet squared is feet squared. So now I have pi, which is 3.14, times 36 feet squared, or squared feet, and my total area of my circle ends up being 113.04 squared feet squared. So now I go back to this formula, which I kind of needed, which is area of the outside equals area of a square minus, that's an ugly square, area of the circle. Area of the square was 144 squared feet. Area of the circle was 113.04 squared feet. I subtract one from the other, and I get my total square feet to be 30.96 squared feet. I'm kind of not really done yet, because if I go back to the question, it says, if the lawn costs 25 cents per square foot, what is the cost of the lawn? Well, I didn't get a cost yet. So now I have to go back to chapter 2 a little bit and look at the cost is equal to 30.96 feet squared times 25 cents. Well, I'll change that to dollars. So $0.25 per squared foot. So over foot squared. Then remember from chapter 2 that foot squared times something over foot squared, these will cancel out. So all I'm left with is this dollars. So 30.96 times 25 cents per square foot gives me a total answer of $7.74. There's no more feet squared because they canceled out in the formula. So hopefully we looked over all the different types of area questions with circles. We have a whole bunch of questions that we'll try out in class. So review these questions if you want to go back through the video and look at these problems and how we did it. If you have questions, you can ask me in class as well. So hopefully you understand.